Yeah, so right before lunch, I brought some cake, but it's only digital. So what I will be talking about today is our DevOps journey. I will start with a short introduction on what I do and who I am. Then we will go back to 2015, the starting point of our journey, and then we will move on in the journey step by step. I will share some learnings that we have. And finally, if hopefully some time is left, I will show you some frontiers that we are currently facing. So in short introduction, so for those of you who might not be from Germany or who might not know Hermes Germany, so we are the number 2 in parcel delivery in Germany, as well as the leader in two-man handling. We are delivering about 450 million to 500 million parcels per year. And we're doing this to the doorstep, of course, and also to 16,000 of our parcel shops. This business can only work if you have a high degree of automation. And you can only achieve a high degree of automation if you have IT. Like we had in the morning already, automate. Same counts for our processes. So we very much rely on digitalization. That's the only chance really to deliver this 450 million parcels. Just a couple of sentences about me. So I'm working with Hermes Germany now for 13 years, and I'm responsible for the custom IT since 2015. And we are delivering with about 60 colleagues digital solution for both private customers as well as commercial clients, corporate clients. So back to 2015, the starting point of our journey, how it started. So the starting point was the reorganization of our IT. So probably lots of you are facing the situation that the company is not very happy with the current situation of the IT organization. So reorganization needs to be conducted. And the task that we were given is that we should move faster. But the question that we asked ourselves is if it is really about working faster or moving faster, or if it should not rather be having smoother processes, less impediments in our way for delivering what we wanted to deliver. And the first answer that we found, or the first solution that we took a look at, was agility. So we used agile frameworks, introduced agile frameworks back then. We did not really aim for DevOps, which was already well known, but not that much in Germany at that point of time. But agility was the path that we chose for us. And in terms of the organization, that was our starting point. We had in the main value stream 4 departments, so a planning team, a dev team, a test team, and an IT operations team. So functionally oriented IT organization, which has some advantages. So you can do that if you want to, because this allows you to optimize each function. So you can have the best testers, the best devs, the best planners, the best operators. So you can optimize it function by function. So that's nice about this organization, but it comes with a lot of drawbacks. So the biggest drawback that we had is that we had walled garden. So whenever the devs were finished doing some stuff, they threw their code over the wall and asked the testers to test. The testers tested and eventually threw the artifact back with some feedback or without feedback. So it was not really about speed; it was more about control, really. Yeah. So moving the tasks as fast as possible out of your own garden. That was the principle. And what we definitely did not have was flow. So we had no idea on how to move a piece of requirement as fast as possible from idea to the actual usage by the customer. So what did we do? Probably like lots of you are also doing, we introduced product teams. And these product teams are streamlined, so adding all capabilities within one team that is necessary for creating customer value. So whenever something needed to be planned, that was done in the product team. Whenever something needs to be developed, that's done in the product team. And if something's to be tested, that's also within the product team. So the overall performance lies in one team. And there's a nice paper. That paper is already 40 years old. It's called The New Product Development Game. And it's a bit complicated to read, but it has one nice quote. This quote is underlying of lots of methodologies we today see in our companies. The ball gets passed within the team as it moves as a unit up the field. So there's a goal. We want to move the ball. And there's a unit. We are moving in a unit. So it's not on the defender to fail, or not on the offender to fail or to succeed. It's on the entire team to succeed. And everyone is moving together with the others. So that was one very important aspect we learned when we created these product teams. So what we achieved then is we came from dedicated developers. And by doing this transformation, we had development experts, so still developers essentially, but they had some testing skills. So the T-shaped profile was something we introduced back then. And we had dedicated testers before, and we of course still have testing experts, but these testing experts learned to develop as well, which allowed us to employ much faster and much better test automation, for example. And before we had different units, as I just showed, and each unit had its own mindset, its own goals, optimizing for their own goals, and now we have a single unit moving together. And instead of focusing on roles, we are now focusing on whatever it takes to get the job done. So when we discover that we have a lot of stuff to test, everyone helps to test. And then we will address this issue and ask ourselves, what can we do so that the testing backlog does not pile up anymore, collectively as a team? And then came along the DevOps principles. And that was, for me, it was really new. So being quite familiar with everything that Scrum introduced and the mindset that Agility introduced. The DevOps principles coined by Gene Kim I think it was in the Phoenix project where he coined that. It just comprises of 3 ways. So really, really easy to understand. So there's the first way, systems thinking. So try to move as fast as possible. Try to move the work through your organizational system as fast as possible, from idea to production. And the second way, as soon as you have done that, amplify feedback loops. So incorporate feedback. And feedback can be product feedback. Does our idea work? Is it used? Do we have an outcome? It can also be tech feedback. So when the pipeline breaks, for example. And the third way, that's a bit the difficult one, it's to introduce a culture of continual experimentation and learning. So we moved on, and the next step that we did is to try to deliver this value really continuously, and to implement this first way. And as you've seen before, the product team comprised of planning, dev, and test, but we were lacking IT operations. So we still had to throw our artifact over the fence, which also kind of worked, but limits you in terms of speed, in terms of flow. And the situation that we had when we started, we had a traditional infrastructure environment. We had our own data center, we had our own networking, we had our own whatever. And within this system, in my opinion, it is impossible for a team to deal with this entire complexity. So the only solution that we found for ourselves was to overcome our own data center and move to the cloud. Not as we've seen before, to move to the cloud because we wanted to get rid of the data center, but to move to the cloud in order to foster flow. And we were very fortunate that the technological evolution helped us a lot. I've tried to show my understanding of this technological evolution in terms of infrastructure. So on the left, we have the very traditional, we have an application running on a machine, physical, virtual, it doesn't matter, as a daemon, as a command line application, whatever. It was kind of the 80s, yeah? And then kind of the mid-90s, when application servers came up, we already had some abstraction layer on top of the machine where the application would run. Then came along Kubernetes or other container orchestrators, which in the end, at least from a developer perspective, is pretty similar, sorry to say. It's pretty similar. And the last step that we today see is a serverless PaaS or function as a service, where the infrastructure really gets transparent. This is why these lines are dashed. And the application appears to run on its own because the underlying infrastructure is invisible to the developer, to the team. And this allowed us to evolve responsibility. On the left, the only chance for responsibility was to set the full responsibility of the running application to the ops specialists. The second, the same. Yeah, you needed application server experts, certified WebSphere, whatever, to run these application servers, to run the application within the application server. And with Kubernetes, you could start to split the responsibility. So you could make the actual team responsible for the application, and the operating team or the provider responsible for the orchestrator or for Kubernetes. And evolving that with serverless PaaS, the app responsibility is still within the team, but the platform responsibility is fully by the platform provider or the platform team. And they are not touching each other too much because the interface between the serverless PaaS and the application is so well defined that there's little interaction between these two parties, or the interaction can be pretty easily managed. And as you hear from my words, we are really trying for this serverless pathway. We have some Kubernetes clusters, of course, left in our estate. And these two approaches allow at least three things. So they allow, as I just described, a clear and reliable responsibility, or responsibility split. Both approaches allow a high level of abstraction. And a high level of abstraction means, in turn, that we have a low entry barrier for new colleagues. Yeah, let them be really new to the company or new in the technology. So it's far easier or far more straightforward to understand how serverless PaaS works compared to what WebSphere did 15 years ago. And the third thing is everything is now coded. So with infrastructure as code, which is only possible, to my understanding, with these two approaches, really, we bring a developer's view to the infrastructure world. We can do what developers did in their applications to the infrastructure. So we can automate everything, we can test, we can replicate pretty easily. What was self-explanatory for developers is now self-explanatory for the infrastructure. And that delivered us continuous delivery. And continuous delivery on its own does not matter. The question is, what do you want to achieve? And what we wanted to achieve is fast flow. And with fast flow, we wanted fast feedback. So we wanted to move as fast as possible from idea to production and wanted to understand as fast as possible if what we did actually works, in technical term, in business term. And that allowed us, in turn, that we did not need to push all the requirements into a single release, which sounds quite simple, but which does a lot to your processes, which does a lot to the testing scope that you need to cover before deploying. So with the small deployments, you have a small testing scope, which means, in turn, that you have a small risk if you introduce this change in production. And that changed everything entirely. So testers are doing a completely different job now than they did 10 years ago. And the same is for the courage that the team has. Of course they are testing, of course they are doing code reviews, but in case that still a bug occurs in production, that's no problem anymore, because what was changed is really a small portion of the code. Yeah, so that the bug fixing scope is also very small. So there's usually an easy way to fix forward. So by introducing continuous delivery, actually we have both the first way and the second way. So it's an easy path to get feedback loops. What we now needed to do is to have work these feedback loops into the team and into the product management to understand what came back from production. And the third thing is about trust and collaboration. And this is what Gene Kim described as the third way, so the culture of continual experimentation and learning. And that allowed us to move from a demand-supply relationship in the old IT organization between business and IT to more a partnership, which in turn allowed us to move from a low trust culture between business and IT. So if I don't push all my requirements now, they will never implement it. So on the left, to blending roles. So we as IT try to understand as much as possible what the business wants, what the business needs. And the business in turn tries to understand how technology works, what can be done with it. It's difficult, but I think it is necessary to really benefit from the possibilities we are offered today on the market. And we finally moved from blaming, so you introduced this bug in production, yeah, you broke it, to a situation where mistakes, of course, are still annoying. Nobody wants to do mistakes. Nobody wants to introduce a bug to production. But everyone understands that this sometimes happens. And that this is not a big problem because it can be fixed easily, usually. So that's a very important cultural shift we achieved here. And the same is about leadership. So it requires a certain leadership. And if you read articles about agility or about DevOps, it's always about the bosses, yeah, that the bosses should get out of the teams and not dictate what the teams need to do. Yes, that's true. So the most important aspect for leaders, they need to trust their teams. By the way, that's the only chance that you have, that you can survive as a leader, because the teams are moving so fast, even if you would want, you cannot control everything. And the second thing is, when all the teams are moving their applications in that speed, what you need to do as a leader is to create a feeling of belonging together. Within the team, of course, but also within the larger organization. So in my case, within the customer IT. So that's leadership more or less in the traditional term if you talk about leaders. But we need to have leadership on all levels. The same is true for the product owner. The product owner must take ownership of the product. So this model is not possible if the product owner does not feel to be the owner of the product. He needs to care for the product, he needs to defend it in terms of difficult requirements that need to be challenged, for example. And the same, and this is, still for the product owner, we sometimes say, yes, of course, he's a leader. But the same is true for the team. We have leadership on the team level. Because the team is responsible for the result that they achieved. They are responsible for the running application. And the team needs to carefully weigh up opportunities and risks. Nobody else is covering for them. They need to do it. So we really have leadership on all levels in our organization. And a pretty new organizational or cultural element that we introduced in our organization is a learning culture concerning business continuity. Because what we found is that with all these moving pieces, it is impossible to have a near 100% availability with how many nines you want. it's a very little chance that you can achieve it, and if you want to achieve it, you have ultra high effort. So we decided to have a good availability, of course. Our business needs to work every day, but to some degree, we accept the risk of failure in our environment. And what we now try to do is to use the possibilities that we gained within the last years. So to use the possibilities that we have from infrastructure as code, that we have from pipelines, that we have from the global data centers that we are offered from the cloud providers. And the way we try to address it, the way we try to implement business continuity is by conducting or by offering disaster recovery days as events. And in this event, you saw the monster on the previous slide, we simulate outage. So literally there's a colleague putting one of these monsters on the table and says, look, this one now broke our data center. So we are simulating the outage, and we are collectively, as the entire unit, as the entire department with 12 teams, collectively restore our application landscape. There was already the question, if you want to recover, you need interconnections and you need this and that. Yes, that's true. But we decided on a different route. We decided on slowify the learning, so moving it really step by step, conducting regular events, and increasing the complexity from event to event, so that everyone can understand the situation, everyone can learn and adopt their applications for the next event. So we started pretty simple. In the first event, the task for each team was to restore one of their microservices. Easy? Maybe. So half of the team succeeded, half of the other teams or the other half did not succeed. Restoring one microservice within one day. Because infrastructure as code is not infrastructure as code. So whenever you think it is automated and you just have to push on run and then it is restored, no, that won't happen unless you tested it. You tested it in such an event. I'm pretty sure whatever infrastructure as code you take that is not tested, it will not work. It will not restore your application. It's at least what we found out. So that was event 1. Event 2 was to restore as many microservices as possible. And we are now in iteration 4, and we are now talking about interactions between applications. It takes time. It's probably not what the company wants. They probably want everything to be restored right out of the box. But that's not possible. It's too complex. So what we try, as leaders, as managers, to let our teams learn step by step. And finally, we have some frontiers, of course. And there was a paper about developer experience from Abinoda. It's a year old now. And in this paper, they found that 3 critical measures are important for achieving productivity of developers. So it's the flow state, and it's another flow than I just described. It's more the mental flow. It's feedback loops, and it's cognitive load. I mean, talking about all the technical details that are covered in this conference, I think everyone can easily understand that cognitive load is really an important aspect. And the same is true for the DevOps principles. So when the traditional DevOps was that, so just an intersection between development aspects and operational aspects, what we today see is rather this picture. So we have BizDevOps, we have DevSecOps, we have FinDevOps, we have sustainability in. And if you want to cover all of that within one team, I mean, you can't have a platform as good as that so that everything of this is covered within one team. It's impossible. So one important task, I think, that we have in our organizations is really to protect these principles. And of course, sustainability needs to address, security needs to address, the business needs to address, and financial aspects need to be addressed. Of course, I will not encourage you to neglect that. But the question is it really part of our value stream? Or is it more, in Kubernetes terms, a sidecar? Yeah, something that needs to be conducted by someone else out of this value stream. So that's, at least for me, one thing that I have in mind when we talk about new processes, new requirements, new corporate rules, whatever, to really protect these value streams. And to summarize, 3 key takeaways from me. So keep in mind the intention of your change. So of course you need Kubernetes, you need containers, you need this and that. But why are you using them? And does an introduction of a certain technology help you for your change, or does it not help you for your change? And keep that in mind. Actively manage the change. Actively manage the technology that you bring to your company in order to do this change, or the processes that you are doing, that you are introducing for doing this change. And finally, at least my belief is that DevOps is very important for a healthy development culture and a high delivery performance within an IT organization. I think it's inevitable. You need approaches like this. Otherwise, you will not be able to deliver in a high performance. Looking for the next 7 years to come. In case you want to you wanted to reach out, this is my contact data, and now I'm happy for your questions.
Thank you, Stephan. We do have a few minutes for a few questions which come up. Yep, there you go. So the first one is, how many product owners do you have, or how many products does a product owner usually have in your company?
Yeah. So in my area of responsibility, we have, I think, 10 product owners. In total, I think it must be 30. We try that one product owner only has one product. But what is one product in a microservice environment? So things fade to some degree. But what we really try is not to mix business aspects for one product owner. So if he or she might have 2 products, they should be out of one family, so that the cognitive load of the product owner is not too high. Because in the end, the product owner is the one who has to deal with all the stakeholders. Let the stakeholders be the business, or let the stakeholders be the customers. And if the product owner really needs to cover multiple different business aspects, in my opinion, it's impossible. What we really try is to have smaller teams, more teams, and more product owners to really cover this responsibility.
Yeah, I'm a big fan of team topologies, and they talk about stream-aligned teams, yep, which is probably the same.
Same, yep.
Yep. So is there still an architecture team? If yes, for which purpose?
Yeah. Yes, we still have an architecture team, and it's still important, or it is important. I'm an old guy, so there are two basic architectural elements that are still important today. That's, for one, is the enterprise architecture. So it needs someone maybe not to understand the entire landscape, but to collect the information about the entire landscape, be able to describe for new initiatives or new colleagues what the landscape is made of. So that's enterprise architecture. And we also have solution architects. And yes, from time to time, they are working very closely with teams over a long period. But in general, they are more consultants. So if a team has a certain question, does not find a solution on what components to pick or how to implement things, these colleagues are quite experienced in development, the solution architects, and they can help these teams then.
Cool, thanks. On what stage, development or staging, or maybe even production, do you do the disaster recovery day? Are you deleting a running microservice for disaster recovery?
Yeah.
Please say production.
Sorry?
Please say production.
No. We are not that brave. Yeah. No, we are really creating a dedicated environment or dedicated projects for setting up these applications. So it's kind of a vanilla scenario that we are creating, which lacks, of course, some realism. But on the other hand, it gives us what we would face if the cloud would be down. Everything would be vanilla in this case as well. So. Yes, it helps to some degree, and it helps not. Yeah, we are not doing it in production, so we are not doing chaos engineering currently. Yeah, maybe something for the next talk. Yeah, in a couple of years.
As a fellow engineer in logistics, where and how in the product team do you integrate employees that aren't technical? Example, roles defining business processes.
Yeah. I need to understand it first.
So I think it's about I don't know, business people within teams who are not technical.
Yeah. We understand that there is a gap between tech and business, or that part of the business, and we try to address this gap. I mean, one easy thing is to invite everyone into product reviews. That's easy, or sprint reviews. What we rather do in the logistics area is that we have pilot users. And these pilot users are a bit closer to the tech people, so that they have learned to listen, to understand a bit more. From these pilot users, we have kind of a spoken word to the rest of the organization. So it's, yeah, we roll out in concentric waves in the logistics part.
I think we've got time for one or two more questions. How do you make developers understand that need to do more than just development of code? Yeah. We keep getting pushback on this.
Yes. I mean, it's talk. Yeah, like automate. This is more about talk. So be in contact with the developers. Explain why this is important. And of course, still developers want to develop. That's why they chose this career path. But I think, I mean, we are not that big. I mean, we are 60 people in my department. We are 300 in total in the company. I mean, we are not small, but everyone understands that he or she does also need to do things that are not in their core area of expertise as well. Yeah. So probably due to the size of the company that we have little pushbacks on that.
Yep, communication as always, I think, it's extremely important.
Yeah.
I'll take maybe one more. How much impacting have KPIs in your team decisions and the team freedom to choose tech improvements?
If I understand the question right, it's about the freedom to choose technology. I'm a bit reluctant to that, actually. So we try. I mean, everyone of us is using either Google Cloud or AWS. So that lays a lot of the groundwork on what technology is possible. We are quite restrictive in terms of a programming language, for example, because we want to be able to exchange not only knowledge, but also maybe persons between the teams. So we need some communality among the teams. But we are quite free concerning like components or other tools, so teams can do whatever is appropriate for them in terms of tooling on top of that. Yeah.
I'll stop it there because it is lunch time, and I think people would like to go. But before we go to lunch, one last round of applause for Stephan. Thank you very much.